Assalamu alaikum everyone. I am Shabanu from University of Engineering and Technology Texla. First of all, I would like to say that I am so ecstatic and grateful to be here in front of you all. Today, I am here to give you a brief description regarding my topic, which is carried baggage detection and classification using multi-trend binary code descriptor. Now let's get into the topic.
First of all, I want to briefly explain why we conduct this research work, so that the audience got the idea and further description become more understandable. Basically, in automatic video surveillance system, baggage detection has a wide area of security applications, like detecting carriage of illegal materials into baggage, detecting unclaimed baggage in public place that can be placed by terrorists for violence, and detecting baggage in baggage restricted super shops. So, to cope up with these, a more robust algorithm is proposed with the vision of ensuring security in public places. As we all know, crimes in public spaces around the world has been increased drastically. Installation of CCTV cameras in busy public and sensitive zones provides a tool to monitor the threat and warn the security team. Nowadays, detection systems based on computer vision approaches have been considered as key tasks for many surveillance applications. But there are some challenges in the detection procedure which are as follows: the change in illumination conditions, complex backgrounds, articulate poses, and outdoor scenes. Now, the objectives. Well, in this research, we are striving to achieve the objectives like help to build up a ground security, to develop a technique that detect diverse baggage and less likely to produce errors, and finally the performance evaluation in association with state-of-the-art methods. In the methodology section, first of all, pre-processing is done. In it, background subtraction is used to extract the foreground region, and contrast enhancement is used to improve the contrast of the image. Then human body proportional model is used to divide the image into parts like upper body part, lower body part, and baggage sample. After that, two descriptors, scalable histogram of oriented gradient and multi-trend binary code descriptor, are used to get the features. Then the computed features from both the descriptors are concatenated into one feature vector. And finally, support vector machine classifier is used to classify them and give the decision as either the person is carrying backpack, duffel bag, wheeling bag, or either the person is without any bag. As a training strategy, support vector machine is used for the erudition of different human body parts and the baggage part. The evaluation of the proposed descriptor is performed on three standard datasets like INRIA, ILIDS, and our own dataset which is collected from Google. Some of our dataset samples for the placement of baggage on human body are shown in the figure. For training and testing, we manually classified image samples as testing samples and training samples. For training purposes, images are divided into three categories: backpacks, duffel bags, and wheeling bags. Apart from these human carrying bag samples, there are also some baggage samples which are also shown in the figure. Now, classification and results. The presented approach was first analyzed to classify that the image regions having human are either with bag or without bag. The samples with carrying bag are considered as positive samples, and those samples in which human without carrying any bag are negative samples. To investigate the samples, we randomly take 30 scalable histogram of oriented gradient features and 20 multi-trend binary code descriptor features. As it is clearly seen in the multi-class evaluation of baggage categories, that our model gives the detection rate of 96.6% with false detection rate of 4%. The proposed framework is also compared with state-of-the-art methods, and it is seen that our model's accuracy is higher as compared to the previous approaches. In order to conclude my topic, I would like to say that in computer vision approaches, our proposed method was not applied previously for the detection and classification of baggage or any other object. The proposed approach deals with the human body parts and the baggage and utilizes a strong relationship between them. We proposed a fusion of two descriptors, scalable histogram of oriented gradient and multi-trend binary code descriptor. And then, after conducting extensive experiments, the proposed method shows better classification accuracy in comparison with other state-of-the-art approaches. At last, I would like to thank my supervisors, Dr. Wakil Ahmed and Dr. Syed Muhammad Adnan Shah, who guide me thoroughly in this research work. And I also thank Emerging Scientist 2021 for providing me this great opportunity. Thank you.